Sometimes we have to look at graphs and by just looking at them determine what its range is and what its domain is of a particular function. So I have three graphs up here and I want to determine is, well, what's its range? Well, first, what's its domain and what's its range? Domain, again, remember, is all the values of x that corresponds to a graph, and the range corresponds to all the y values. So in this particular one, if I'm looking at all the x values, I see that there are x values to the left of this point, to the point of number 4, but none to the right. And if I look at this graph continues on out with an arrow all the way up to negative infinity. So I can say that my values of x are all x such that x is less than or equal to positive 4. So that's my domain on this particular one. I could also write that in interval notation, which is negative infinity, not negative 8, negative infinity to 4, a hard bracket on 4 and a soft bracket on negative 8, because interval notation tells me that the hard bracket tells me that 4 is an inclusive answer, and the soft bracket tells me that it is not an inclusive answer. And we'll see that a little bit more defined here in a little bit. So those are my x values of my domain. My y values are all the values that correspond to the y's. And it looks like my first y starts right here and continues on up. So I would say that all my y values, all my solutions are y such that y looks like it has to be greater than or equal to 0. And again, I have no solutions below this. They're all above it. And this arrow, although it looks like it's starting to level out, based on the trajectory, it's still increasing. So I'd have to say that it's all my values from 0, a hard 0, because 0 is an inclusive answer, all the way to positive infinity, if I were to write the solutions in interval notation. All right, let's compare and contrast a little bit to the next one. Here I have a function. It looks linear, looks like a line, looks like it's both going to positive and negative infinity from both sides. So this one tells me then that my domain, all my x values, are all real numbers. All x such that x is all real number. And then likewise, in an interval notation, that's from negative infinity to positive infinity. And then my y values, it looks like since these lines both continue on forever, that I'm going to get every y value or every y input will be a solution. So likewise, my y's will also be from negative infinity to positive infinity, if I can draw that correctly. Okay, the last one over here is I have a piece of a graph. And I want to determine what is its range and what is its domain. First of all, you can notice that there is a circle here that's not filled in as compared to that one. And that, if we remember, what that means is that this graph approaches this point, but does not include that point. So all my x values in this case are all x, such that x is between, so x is greater than negative 2. Sorry, I gotta be small here, I don't have much room. Negative 2, x is greater than that, but less than 1, 2, 3, 4, or equal to it. Or in interval notation, negative 2, soft, 4, hard. Because negative 2 is not part of the solution set, but 4 is because it's filled in. And likewise, y is similar to that. What are all my y values? Well, in this case, y values include, if you use my pencil, they start right there. Not just right there, but right there. So I would say that my y values are all y such that y is 0 is my lowest value. And it looks like it equals 0 all the way up to 1, 2, 3, 4 in this case as well. Or in interval notation, 0, hard bracket, to 4, hard bracket. So all my range coordinates, or all my range, is from the values between 0 and 4. So sometimes when we have a graph, we can look at and determine what are its domain values and what are its range values as we go ahead and expect some of the things we can discover.